Hi folks, back again for another round of assembling pie plates. This was the previous assembly that I put together using a case plate. And the case plate, as you can see here, is just some little plastics with some standoffs. And for my next assembly here, I've got several Raspberry Pis, but I'm only going to use one of them. And the one I'm going to use is a Raspberry Pi 4. One of the things I want to show you here is the difference between a Raspberry Pi 4 and a Raspberry Pi 3D. The 4 here has two mini HDMI ports on it, these two, and the 3B has a large HDMI port on it. In my last video, I did outfit these with cards. This has a 64 gigabyte card on it, and this one has a 32 gigabyte card. And I also used a 32 gigabyte card in the case plate version. So the first thing that I need to do here is I'm going to use a DINplate. And the difference between the DINplate and the case plate is that the case plate I can pretty much set on a shelf somewhere like this, right? Whereas the DINplate is set up to mount on DIN rail, which for industrial applications, which this is not really going to be an industrial application, but you can see here, this is a plastic piece with a DIN rail mount here. So since I've done this before, I don't need to do a whole lot of looking at the instructions. I'm going to be building this in the same order that I built the last one. So I'm going to put the DINplate, I'm going to put the Pi here on the standoffs, right, with my ports facing out this way. And then I'm going to use a power plate, and the power plate again has a battery in it with a real-time clock, so that's kind of useful. So the first thing I'm going to do is put these standoffs into these little holes using these screws, and I've got all my tools and everything set up ahead of time. Since these are kind of symmetrical, I could have the smooth side facing out if I wanted to, but I like the rough side facing outward, the textured side here. I don't know if you can really see the texture on this, but that's the side that I like to use here. So I've got several long screws and several short screws. And let's see how many of each I have. I have 4 long screws, so that's kind of, well, I have 4 short screws also. So I'm using the long screws in any case, and then I'll use the short screws on the top to attach the Pi itself since it's thinner, right? So that's why I'm using the long screws here. So stick the long screw through from the textured side, put on the standoffs, and you can just finger tighten these to start with. We had Jerry Wassinger, the man who started Pie Plates, as a guest on our webinar a couple weeks ago, and he is going to be appearing on the next webinar also. So there are the standoffs. Anyway, the next webinar is October 22nd. So if you're seeing this, probably you'll be seeing this afterward, because I plan on putting this on YouTube as a continuation of the last one, but it may be over by then, by the time you see this. But you can find that on my YouTube channel on Automatici, which is probably where you'll find this video also. So once again, I place my Pi here. This protects these ports, and it helps to have a little screwdriver to start these, since my fingers don't work so good for these tiny screws. So once you put the standoffs on, go ahead and put the Raspberry Pi itself on. Again, very convenient to have all your screwdrivers and things ready. It's really all you need for this is screwdrivers. That pretty much handles everything. Some of these, for us older guys, are really hard to get your fingers in here, so I tend to use tools wherever possible to at least kind of brush things into the correct hole. Also, having a little more light can be helpful. Currently it's October and the sun's out, so I can see pretty well, but we'll see how this video turns out. Once again, everything is kind of lined up. It can help to loosen the screws a little bit when you're putting the final screws in. That helps you line the screw up with a hole a little better than I've got here. There we go. So now you can see I've got the Raspberry Pi attached to the plate. And then we have these standoffs right here. And these are tall standoffs to make sure that the Pi itself fits in. And you can see kind of how this is going to hang on the plate like this, with the ports facing upward. So we'll put our next standoffs in here. This is a very handy setup for hobbyists and even people doing kind of industrial Pi applications. We had a very good webinar a couple weeks ago. Well, it was actually about a week ago. And surprisingly, Jerry mentioned that there were more applications in industrial applications than there were in home applications, according to Raspberry Pi themselves, which I was surprised to hear. These are very inexpensive. They're kind of on the throwaway level from a control standpoint. There we go. You could probably buy 10 of these setups for the price of one small Allen Bradley PLC controller. So here is our standoffs with the Raspberry Pi attached. You can see the screws sticking out the back. The next thing that I'm going to put together here is the power plate. And what the power plate does is distributes power to everything. And it has a nice little fan, right? So you can see the fan here. You can see the header that snaps onto the pins. You can see some I/O connections here. And I still haven't looked at what these I/O connections are used for, but I will do that after I get this built. We'll figure out what everything's for. As with last time, there is a battery included with this, and this battery, among other things, keeps the real-time clock. There is a real-time clock on this, and it keeps the real-time clock going even when you are not connected. Once again, there is a plus sign on the battery itself, and there is a plus sign right here facing up on this little battery holder. So you stick the battery in just like this, slide it on in there, make sure it's firmly seated. And then once again, a lot of this stuff kind of lines itself up. The header, right, you can see right here, you want to stick the header on, make sure that the pins line up correctly. Takes a little bit of jiggling around to make sure that it lines up right. As a matter of fact, it looks like looking at it from this end will allow you to line things up the best. And there we go. Make sure that everything is well aligned before pushing things together. You do not want to bend these pins. And it kind of slides together pretty firmly here. Actually, you know what? I forgot, before anything else, there are some heat sinks. And so I was pushing it together a little bit early. These are the heat sinks, and once again, I did this in the last video, but these heat sinks match up with the components, and they just have adhesive paper on them. And you can kind of tell what they go onto. And I have been playing with these pies a little bit lately, and they really do get hot. So it's a good idea to put the heat sinks on. Once again, here is the processor itself, and that is one of the things that gets the hottest. So this matches the processor in size. So I'm going to peel the adhesive backing off and attach it to the processor. Once again, right here. Stick the little heat sink on. There is a long and wide heat sink here for one of these. And there is a long and wide, I believe this is memory piece. So we'll stick that on the, I think, the memory chip. Might make things last a little bit longer with that fan running. Once again, the purpose of the power plate is to distribute power among all of the plates, and also to cool the pie itself, which can extend its lifetime. So there's two of the heat sinks on there. And then the third one is very small here, and it lines up perfectly with this little chip here, which once again, I'm not sure what that chip is. I have a book that tells me all that. I bought several Raspberry Pi books online and in the stores. I go to Micro Center, which I found several of these. I've been to the one in Marietta, Georgia, near Atlanta, and I went to the one in Washington, D.C. recently and bought some pies there. But now you can see I've got the heat sinks on here, and Jerry has designed this such that the fan fits right over the heat sink. There we go, just like that. So once again, line this up. Make sure everything's square before pushing them together. And it's just like a little erector set kind of thing. So now I've got my power plate attached. The next step would be to take the standoffs for the power plate and screw them right into the top here. Make sure everything lines up. And then I have two other plates here. I have a DINC plate, which is the DINC on steroids, I guess. And then I have a thing here called a motor plate. And the motor plate, I have a feeling, is going to get somewhat hot also. So I'm going to put the motor plate probably on here first. Since this fan blows, it might pull air from the motor plate. And the DINC plate is less likely to get as hot. So I'm going to put that on next after I get these standoffs put on. And it appears that no matter what you do, you're going to have a couple of extra standoffs. But you want to use the standoffs that are in the bag with each component, because they are set up to the height of the component. So I wouldn't want to get these mixed up and put the wrong standoffs on and then find out after I had everything together that I had the wrong ones lined up for the next one. Okay, and there's my fourth standoff. That completes the power plate. As I mentioned, next we'll do the motor plate. And they're actually, before I do that, I'm going to take a look here at where the pins come out on this. So these are the connections for the motor plate, and I can see a piece of padding here. This is just on the header pins. And then I'm going to take a look at the DINC plate and see how these line up. Looks like this goes like this. And the reason I'm doing this is the DINC plate, this was shown to me by Mike O'Day, who's a member here at the Academy, and he showed me that these headers right here, or these connections, actually stick out a little farther. So if I put these on in the wrong order, you can see here I can't get at the screw terminals for the motor plate. So I'm going to actually change my mind here about the order that I put these on, and I'm going to put the DINC plate on here first. And what that does is that allows these screw terminals to stick out a little bit farther than these screw terminals, which the fan will be pulling air from the DINC plate, which is not ideal. The other thing that I will need to do is I will need to set these jumpers correctly. So these are the jumpers for the addresses, and I want these to be address 1 and then address 2. So in the order that I'm assembling them. I don't have to do anything for the motor plate. Once again, take this little pad off the pins. You notice here these red and black wires kind of get in the way. So you want to kind of pull them out of the way of the this header here, or of these pins. So once again, I'm going to put this on in this order. Put the DINC plate, look through the side and make sure you're not pinching these wires. And push them together. Make sure everything's lined up real good. These aren't terribly expensive, but you don't want to bend the pins and have to replace them. Here we go. And these are in binary, and they go in order. So this will be 1 and the next one will be 2. So you can pop off these little jumpers. And I have not powered these up yet to see what they're going to look like. But take off that one. Take off this one. So that should be a binary 1. And the next one, I'll leave the middle the middle jumper in for a binary 2. If you have a set of needle nose pliers, it may be easier to get these jumpers off that way. So once again, go into this is a DINplate plate. So you want to go into the DINplate bag and get your standoffs out. These may be the same height as the motor plate, who knows, but go ahead and leave them in the bag until you're ready to put them together. There we go. Screw the standoffs in. There are no attachments on the back side, fortunately, right? This is where the DIN rail attaches. There's no connections here, but there are connections on the top, there are connections on the bottom, and there are connections on the outside. And notice that the power plate sticks out a little bit farther than the DINC2 plate, which will stick out a little bit farther than the motor plate. Right, so you'll see a kind of a tiered effect of these terminals here, where in order, this is the farthest in, this is the next highest, and these are the highest. So that kind of tells me what order I wanted to build these in. Of course, if you made your attachments ahead of time, then it wouldn't matter too much what order you did it. But that snapped right in there. Once again, going to go to these jumpers right here. And there are some other jumpers, 5 volt DC, VM1, VM2, and it looks like these are for, it looks like external connections to run the motor. So if you want to run a little higher voltage, you probably can right here. Once again, I'm going to go to the PiePlate address select. This one even says PiePlate address select on it. And I'm going to just take a guess here and go for the binary 2, which is the middle connection. And this comes off fairly easily, these little jumpers. So now I've got my middle jumper here, and down here, it's kind of hard to tell, but I have a jumper on one end, the lowest number. So this is all kind of ready to go here. Once again, there are some more standoffs, and I'll go into my motor plate connection. If for some reason you need to take this back apart, it's not terribly difficult. So I'm building this just for demonstrations. But when I connect my wires, I may have to take things back apart a little bit. Once again, stick the standoffs on. I do have one more plate called a Tinker plate, and I think I'm going to use the Tinker plate hat with this little 3B just to play with in the other room. I've kind of set myself a little lab up with an oscilloscope and function generator and a lot of little electronic gadgets to play with these Raspberry Pis, and I have some Arduinos and things also. So kind of having a lot of fun in there. I usually do a lot of industrial automation things, but this has been very enjoyable playing with the Raspberry Pis. There we go. We've got the standoffs together, almost together. Now you can see here there are more of these what I would call kind of hot chips here on this motor plate, and they may get hot too, like this little processor here. And so if you wanted to, there are other heat sinks that come with other kits, and you can stick the heat sinks here on the outside, and that would help to dissipate the heat a little bit. So that's everything as far as the pie plates goes, and the only thing left is putting the other DINplate on. Once again, I have these leftover screws. Just stick them right in the end. Very easy so far. And I did all this without even reading the directions. I may regret that later when I have to power this up and do things with it. There we go. So now I have a full assembly with a DINplate. Looks like this. There's the side view. And then I have the full assembly with the case plate. I'm going to grab a piece of DIN rail here real quick, clip it on there, and show you how that works. So this is your typical DIN rail. And you can see these little spring-loaded pieces down here and these levers that they've given to set these up. And you just hang it on your DIN rail and it snaps right on, just like that. So nice and industrial, ready to go. Thank you for watching. And this has been a presentation of the Automation Academy showing you how to build some Raspberry Pi accessories pie plates. Thank you very much.